All right, so this is Unit 2, Lesson 2, Day 1. The topic, I already wrote it in here, is standard form and slope-intercept form. So we're going to talk about both of those forms today. So first, a little just introduction as to what it means to be linear. So we already talked about relations just being this connection between x values and y values. So when all of those points end up falling on a straight line, we call that a linear relation. And so it ends up looking something like this. And you guys have seen lines plenty of times before. So instead of just listing out the ordered pairs, we write those relations as equations. So this is the equation for this line right here. X plus y equals 8. So what that means is if you take every single one of these points and add the x and y value together, they end up equaling 8, every single one. So all the way from the point like 0, 8 to the point 8, 0, and you've got the point 4, 4 in between, all of these would fit into this equation. So that's just what it means to be linear. The first form that we're going to be looking at is standard form. So linear relations, a lot of times you'll see them in standard form, which looks like this. A times x plus b times y is equal to c. And so you've got a, b, and c. So this is a list of rules that we have to follow, and this is how we're going to put them into standard form down below. So a, b, and c have to be integers, meaning either positive or negative whole numbers, can't have fractions, can't have decimals. That's one rule that we have to follow. A has to be greater than or equal to 1, meaning the term that's in front of the x right here has to be positive. If it's negative, then we're not truly in standard form and we need to change that. And then the GCF of A, B, and C is 1, meaning there's not a common multiple or a common factor that you could divide out of all of the terms. If there is, then you would have to divide it out. So we're going to look at a few of these examples, get them into standard form. So the first thing that I want you guys to do is start by looking at this form, making sure that it's actually in the right order, like the x term, the y term, the equal sign, and then the constant on the other side. So we're going to look at number 1 first. So this form is fine. We have the x term, the y term, the equal sign, and the constant on the other side. So then we just move down our list of rules. So first rule, a, b, and c are integers. So we have a -5, a +6, and a -12. Those are all integers. Next rule, a has to be greater than or equal to 1. That's the rule that we're breaking right now. So this is a, and a is a -5. So what we do is we just fix whatever rule is broken. So what we have to do with this whole equation is we're going to multiply or divide, whichever way you want to look at it. We need to divide everything by a -1. So I'm going to do that on both sides of the equation. Divide both the terms on the left and both the terms on the right. So when I take -5 and divide it by -1, I just get 5 times x. And then 6 divided by -1 is a -6 times y equals, and then we had to do it on the right-hand side as well. So -12 divided by -1 is a +12. So now we fix that. They're still integers, they're still in the right order. The GCF is 1, so 5, 6, and 12, there's nothing that all three of those numbers have in common. So this is standard form. The reason that we have all these rules is because there needs to be one right answer. We can't have this be the right answer and this be the right answer. So as long as we're following all the rules, everyone should come up with the exact same equation at the end. So that's one example. Let's look at number 3 as another example. So start with the order. So the order is we want the x, the y, the equal sign, and then the constant. So very first thing we need to do is get this constant over to the right-hand side. So I am going to add that 24 to both sides. So it cancels from the left, and then I'm adding it to the right, like this. So now the form is right, the order is right. A, B, and C are supposed to be integers. They are. We've got 9, 6, 24. No fractions, no decimals. The first term is supposed to be positive. That's a +9, so we're good there. In our last rule, the GCF is 1. So 9, 6, and 24 aren't supposed to have anything in common, but here they do. They are all multiples of 3. So 9, 6, and 24, we can divide all the terms on each side of the equation by 3. So as long as you do the same thing to both sides, reduce the whole equation down. So 9 divided by 3 is 3 times x plus 6 divided by 3 is 2 times y equals 24 divided by 3 is 8. All right, so now it's completely reduced, still in the right order, still integers, leading term is still positive, so that means that this is our final equation. And like I said with number 1, the reason we have to do all this is because this way, this is the one right answer. We can't say that like this is the right answer, this is the right answer. We need to all be able to agree on one. All right, last one we're going to look at is number 5. So check the order. We've got ax, by equals c, that's good. First rule is supposed to have integers, and we don't. These are fractions. A and B are both fractions. So to clear out the fractions, what we're gonna do is take a look at the denominators. We have a 4 and a 3. So we're looking for our least common multiple that would cancel both of those out. So we're looking for a number that's both a multiple of 4 and a multiple of 3, and that would be 12. So we're gonna take the equation, both sides of the equation, left and right, and we're gonna multiply everything by a 12. Okay, so when we multiply this first term by a 12, 12 times 3/4, we do 12 divided by 4, it's a little trick. 12 divided by 4 is 3, times 3 would be 9 times x, minus, do the same thing here. 12 divided by 3 is 4, times 1 is still 4, times y, equals, and then you have to multiply 12 by that 1 as well, then we get 12. Okay, so let's go back to our rules. Still in the right order, I didn't change the order at all. Now these are integers, 9, -4, 12. This leading term is supposed to be positive, which it is, and the GCF, so 9, 4, and 12, they don't have anything in common, so there's nothing else that I could divide out like I did with number 3. So this is our final answer here. So I kind of saw an example of everything that we would need to fix here, so you guys could work on some of those standard form examples. All right, so that was our first type. Our next type that we're going to look at is slope-intercept form. And you guys definitely saw this in Algebra 1, probably in geometry as well. So linear equations, a lot of times we'll see them in slope-intercept form, which is this. We've got y equals mx plus b. And since we've been talking about functions as well, you might also see it in function notation. So instead of having a y, you might have f of x equals mx plus b. So you might see that. Those are totally interchangeable. Y and f of x mean the very same thing. M is the slope, and B is the y-intercept. So it's really easy to pick out some of the common features of these because they're just like looking right at you when you have it in this form. So we've got 4 different types of slope. So slope is the rate of change. Think rise over run, how fast it's growing, how fast it's shrinking. There are 4 different types of slope that you might see, so we are going to sketch them below. So you might have a positive slope. That would look something like this. So we've got our coordinate system like this. I'm going to use just a different color so the line stands out. A positive slope would be just an example like this. Right, so as we move from left to right, this line is growing, this line is increasing. That's what it means to have a positive slope. We could also have a negative slope. So again, set up our coordinate system here. Negative slope means just the opposite. As you move from left to right, your line is falling. And it might be super steep, it might be not so steep. The important part is that you can see this decrease happening as you move from left to right. You could have a slope of 0. So we set up a coordinate system here. Slope of 0 means that you just have a horizontal line. Your line is just going right across. It doesn't matter where it falls as you go up and down. The point is just that it's going straight across like that. Or the last one is that the slope comes out and it is undefined. And what that means for a slope to be undefined is instead of being straight horizontal, it is straight vertical, like this. So that is the 4th and final option. So you guys might see any slope over the next few days that looks anything like any of those 4. All right, so we're gonna look at a handful of examples. So these ones, we're supposed to be writing the equation in slope-intercept form and then graphing. So 7 and 8, they are written in slope-intercept form for you already. So I'm not gonna show you those. I'm gonna show you ones where we actually have to get it into our slope-intercept form first. So I'm gonna show you 9 and 10. So basically what that means is you need to get the y by itself. So this one, I'm gonna start by subtracting x from both sides. So subtract the x from the left, and then we'll subtract the x from the right, and I wanna make sure that everything ends up in the right order. So you subtract the x over and you already had the negative 15. Then to get the y by itself, we're gonna divide by 3. So divide this term by 3, and then this is technically a -1. So I take the -1 and divide that by 3 times x, and then I take the negative 15 and divide that by 3. So that's my equation. So I start with that. So these ones, the reason I didn't do these is because they were already in slope-intercept form. So I get these into the right form, and then I'm gonna graph. So here's the way that works. I start with my y-intercept. So my y-intercept is the value that goes somewhere on this line right here. So my y-intercept is a -5. So starting from the origin, I go to -1, 2, 3, 4, 5. You plot your very first point right there. Then what we do is we use the slope to plot more points. So our slope is -1/3. So that means the rise over run is -1/3. So I can do that one of two ways. I can either go down 1 to represent the -1, and then to the right 3, plot a point right there. And then I just like to repeat that pattern until you run out of space. So then run down 1 to the right 3, and then we're out of space. We don't have space to go to the right 3 again. So you could also do the perfect opposite. Instead of going down and to the right, you could also go up and to the left, and then you see it's still falling perfectly in line there. So we could go up 1 and to the left 3, and then we're out of space. So once you have all the points that you can, you just connect the dots, put arrows on both sides to show that even outside the grid, that graph would keep going. And that's what the graph looks like for number 9. All right, so number 10, we're gonna do the same thing. We're gonna get this into our slope-intercept form. So I want the y to be by itself. So it's already just a positive y on the left. So I need to subtract this 4x over to the other side. So it'll be -4x. And then since this is a -1, I'm going to add 1 to both sides. So just kind of some addition and subtraction. I get everything over to the right-hand side. So now it's in my slope-intercept form. So just like number 9, I start with my y-intercept. So +1, start at the origin, go up 1. That is my y-intercept right there. And then my slope is a -4, so you can think of that if you want. Think of it as like -4/1. So I go down 4, 1, 2, 3, 4, and then over to the right 1. Okay, and then you can repeat that process. So go down 4, over to the right 1. Then I'm out of space, so I can reverse. Instead of going down and to the right, I can also go up and to the left. So I go 1, 2, 3, 4 to the left, and then I'm out of space because I only have 3 more units up there. So now once you fill up your grid, you just connect the dots, arrows on both sides. Looks like that. So both of these happen to be negative slopes, but you could of course have a positive slope where you're going up and to the right, which would also take you down into the lefts. All right, so now our couple more little topics here, vertical and horizontal lines like we had on the front. So this one, see this is our vertical line right here. So this, as you go over to the left, every single point on this line has the same x value. It's moving up, it's moving down, but it's not moving left or right at all, which means a vertical line is always just x equals, and then it's whatever this x value is. So all of these have an x value of -3. So you just say x equals -3, and like I said, all that means is that it's just a straight line where every single x value is -3. The y values are all different, but the x values are all the same. So horizontal is the opposite. This graph doesn't move up or down at all. It's the same y value the entire time. So horizontal lines are always a y equals, and this y value is up 1. So these are all points that have a y value of 1. All right, so that's what the equations look like for vertical and horizontal lines. Vertical line is always an x equals, horizontal line is always a y equals. It's the diagonal lines that have a y and an x like these ones do. Okay, last little topic, parallel and perpendicular lines. So to recognize parallel lines, the slopes are identical, okay? So the exact same slope. Same sign, same number, everything. Perpendicular lines are opposite reciprocals. So what that means, opposite means one's positive, one's negative. Reciprocal means if you have like 2/3, the reciprocal would be 3/2. So we're gonna look at a couple of these examples and just determine if they're parallel, perpendicular, or neither. So let's look at number 13. So number 13, in order to figure this out, we want them in their slope-intercept form so you know what the slope is. So this one, we wanna get y by itself. So we can subtract the 10x. So we subtracted the 10x here, it joins the +5, and then to get y by itself, we divide everything by 5. So divide this by 5, divide this by 5, and divide this by 5. So this one has a slope of -2. So let's see what this guy's slope is. So we need to get the y by itself. So I'm going to subtract the 16, so we'll have -x minus 16 is equal to 2y. All right, so now this, I divide everything by this 2. Okay, so divide, this is technically a -1. Divide that -1 by 2, divide the 16, -16 by 2, and then divide this by 2 and the y is by itself. So now this is the slope. So this is a -2 and a -1/2. They're not identical. They're also not opposite reciprocals. They are regular reciprocals because one is negative and the other is negative. So these ones are neither. They are neither parallel nor are they perpendicular because they didn't fit into either one of these categories. All right, last one I want to look at is number 16. X equals 2, remember that is a vertical line. And then y equals 2, that is a horizontal line. We learned that up here. So something that's vertical and something that's horizontal, those are perpendicular to each other. This one has a slope that's undefined. This one has a slope of 0. And those are technically reciprocals. So these are perpendicular. So if you ever see one vertical, one horizontal, you can know that they're perpendicular.